Alright everyone, in this video I'm going to show you why perpendicular lines have the negative reciprocal slope of the original. So, if we have a coordinate system here, and let's say our starting line has a slope of, let's say, 2/3. We know, just from our formal education, that the perpendicular line is going to have a slope, if this one was 2/3, this one's going to have a slope of -3/2. So down 3, right 2, bam, bam, bam. And we know that this angle right here that it creates is an 90-degree angle. But why? Why is that the case? Well, I'm going to show you. All right. So we know for any line on the coordinate system, we know that the slope, or m, is just the tangent of the angle that it creates with the graph, right? Because that's just, y over x. M is just the tangent, okay? And right now we're trying to find what the slope is when we add 90 degrees to the angle or subtract 90 degrees. In this case, let's just say we're adding 90 degrees. So this is kind of 90 degrees. So we know that's 90 degrees. So right now we're trying to find m prime, let's just call it, when we have our tangent of our theta plus 90 degrees. It's kind of excessive there. This is the expression for the slope of the perpendicular line compared to the original. So now we're going to simplify this. We know that tangent of theta is going to equal cotangent of 90 minus theta. Now, before you click off, there's a very simple explanation behind this. This isn't just memorization. So we know that if we have a triangle here, let's just say this is theta, okay? We know sine of theta is going to be this side divided by that side, okay? Or opposite over hypotenuse. And we know that this is equal to the cosine of 90 minus theta, because look, this side right here is equal to 90, this angle here is 90 minus theta, right? Because this is a right angle, then all the angles must add up to 180. So 90 plus whatever theta is, plus 90 minus theta, that just equals 180. And the cosine of this angle right here would just be adjacent over hypotenuse, so this side over that side. So the sine of this angle is that side over that side, and the cosine of this angle is that side over that side. Therefore, these must equal each other. Okay, so that's the simple explanation for the sines, and it's the same thing for tangent and cotangent, but you know what? I'm feeling generous today, so I'll explain it again for tangent and cotangent. We know that if this is a right triangle, and this is our theta here, we know the tangent of this angle is this side divided by that side. And since we now know that this angle is equal to 90 minus theta, the cotangent of this angle would just be this side over that side, right? Because tangent is opposite over adjacent, and cotangent is adjacent over opposite. So the cotangent of this angle would just be adjacent over opposite. So they're the same thing. So these things, they're equal. Don't mind that here. So now to the main focus of the video. We're trying to simplify whatever this is. So we have an expression here that I'm going to call theta plus 90. I'm just going to call that A. Okay, it's just a simple variable that we're going to use to simplify this using this property here. So we know that tangent of A is going to equal cotangent of 90 degrees minus A. And for this whole video, we're assuming that the angle measure is in degrees. So we're going to bring this down here. I'm going to slide you down over here. So now we know that tangent of A equals cotangent of 90 minus A. So tangent of A, or tangent of theta plus 90, is going to equal cotangent of 90 minus theta plus 90. Got a little cut off there. You guys don't care, right? So there's a 90 minus theta plus 90. So 90s cancel out. So we are just left with cotangent of negative theta. Now what? Well, I'm going to do a little magic here. We know that cotangent is an odd function. An odd function, for those of you that don't know, if we have like f of x, that's our function. For any odd function, f of negative x equals negative f of x. So an example of an odd function would be the f of x equals x cubed graph. So if we plug in a negative x here, it's just going to be the negative of what the f of x would be. Okay, that's probably a bad explanation. If you guys need help with understanding what, wow, this video is 8 minutes long already. Oh my god. Just look up odd functions on YouTube, and you can get a sense of that. So this thing is just going to simplify to negative cotangent of theta. Wow. Where does that bring us? So now we know that the slope, remember, this m equals slope, of the perpendicular line is going to be the negative cotangent of theta. In other words, our original tangent was going to be 2/3, right? So tangent of theta, oh, you guys can't see that, was originally 2/3. So the tangent of theta plus 90, the perpendicular one, is going to equal the negative cotangent, and the cotangent would just be the reciprocal of the tangent. So it'd be 3/2. And that is our explanation. So that's why the perpendicular line has a slope of the negative reciprocal. If you guys like, don't forget to subscribe to my channel and like this video.